Hi there, my name is Eraser and this is Man Magic. It's been a very long time that we have not seen each other and me uploading videos, and I'm very sorry guys because I'm still a grade 12 student and I'm still studying. And so the first time I actually disappeared, which was somewhere in August until December, I was actually having the first part or the first semester of my online class. And then on January until this month, like somewhere, some days in this month, until a few days ago, I was having my last part of my online classes. So at this date, at this very moment, since we just finished, I can now give you guys several math videos, lots and lots of math videos in order for you guys to be entertained at this summer vacation. We're not just going to tackle about mathematics like raw computation, but we're also going to learn more stuff such as the importance of several math lessons, or a specific math lesson, the application, and what does it have to do with our lives. So it's actually beneficial, especially for many people who struggle to understand mathematics. And aside from this, we are also going to continue the part 2 of deriving equations and formulas, which I have not been given to you guys in the last time after the part 1 of this episode. So as you can see, I'm in a different setting. It's because my parents had put up a new business, and so today I'm actually working to help them, and I'm serving as a salesman, and I sell donuts and milk tea in the shop. So since I am in this setting, I cannot actually bring my whiteboard and my whiteboard marker because first of all, it's very far and I have to bring it back and forth because there's so much space to store them. So all I have to do then is just to use software. I'm bringing my laptop right now and I'm using Microsoft whiteboards because it's much better compared to using just ordinary whiteboard and whiteboard marker. At least here you can actually understand what I'm trying to say and hear the words, computations that I'll be making here. You can see them very clear. And so what are we waiting for? Let's start. But we're actually going to have the part 2 of deriving equations and formulas. Remember that in the last time we talked about deriving simple equations and formulas. Now we're going to tackle more complex equations, such as the formula for final velocity, which is equal to initial velocity added to acceleration multiplied by time. And so how do we derive that formula whenever the initial velocity is missing, whenever time is missing, or whenever acceleration is missing? Well, the different formulas that I'm going to give you right now, or the ones that we're going to derive, are just only frameworks of the actual formulas. Like just the example that I gave you a while back, that will actually be turned into a framework, which is A is equal to B plus CD. And now we're going to tackle about those formulas and other kinds. So let's start. And so today you can see on your screen right now the different formulas we have, and they're just not having only one sign, but actually 2 or more signs. So we have here a combination of an addition sign and multiplication sign, a subtraction sign or a minus sign, and a multiplication sign and a division sign. And also we have here a formula that involves a squaring operation, and then 2 group terms separated by a division sign. So let's start with the first 2 formulas. You can see right here we have here A is equal to B plus CD and A is equal to B minus CD. A is equals to B plus C, D. And then its negative counterpart, which is A equals B minus CD. So let us try to write the formula whenever B is missing. So whenever B is missing, the best way here is to move positive CD towards the left side of the formula, causing it to become negative. So that is negative CD plus A equals B. So let me just rewrite that. So we have here B equals A minus CD. Next, we have to write the formula whenever C is missing. So since C is together with D, even though that they are separated by multiplication sign, it means that these shall go together. So this means that we have to eliminate D, but before doing that, we should first move B towards the left side of the formula. Then we will have that here, that is negative B plus A equals CD. Then right after that, we're going to divide both sides by D. Also, you have a formula which is C equals A minus B, the quantity of A minus B all over D. Alright, so next is when D is missing. If you guys want to try, no problem. Feel free to pause the video. So when D is missing, same thing, just like how we get C. All we have to do is just to eliminate C and not D. Right, so let's just move B towards the left side of the formula, causing it to become negative again. Negative B plus A equals CD, and then we eliminate C. And then we will get formula which is D equals quantity of A minus B all over C. Right, so these are the corresponding formulas whenever one of the terms are missing in this type of formula. Now let's move on to the negative counterpart of this formula, which is A is equal to B minus CD. So how about if C is missing in this type of formula? We're going to make this one first to solve. So whenever C is missing, same thing is like how we get this two formulas. So we have to just move B first towards the left side of the formula, causing it to become negative. Negative B plus A equals negative CD. And then since negative CD is like negative 1 times C and times D, we have to eliminate both D and the negative sign, the negative 1 I mean. So we're going to create a fraction that has negative CD in it and has negative D. In order for us to eliminate the negative sign in D as well. So negative D is like saying negative 1 and D. So once we get to divide these two terms, it's like eliminating negative 1 and eliminating also D. And so we also have to divide this side by the negative D. Alright, so we're going to be eliminating the negative sign and also D. And here we're going to have a change of sign in the numerator. So instead of positive A a while ago, it becomes negative A, and instead of negative B, it will become positive B. The reason why is because negative signs are not allowed in the denominator, and so these negative signs will be moved towards the numerator, and that actually just means negative 1 here. Now our solving formula would then be C equals quantity of B minus A all over D. Next, if B is the one missing, we would have them to move negative CD towards the left side formula, causing it to become positive. Positive CD plus A equals B. So that's how simple it is when we're getting B. Right, so we'll just have this A plus CD. Lastly, whenever D is missing, same thing, just like how we got C, all we have to do is move B towards the left side of the formula, causing it to become negative. Negative B plus A equals negative CD, and then we have to eliminate negative C. Right, so we're going to eliminate here the negative C, and then we're going to have a change of sign here in the numerator on this side. This one become positive, this one become negative. Then our solving formula would be D equals quantity of B minus A all over C. So here are the corresponding formulas whenever one of the terms are missing in each of these type of formulas. And now let us move on to the next type of formula that involves double and multiple operations. Right, let's move on to these next two. We have here A is equal to BC plus DE, and A is equal to BC minus DE. A equals BC plus DE. Right, here are two formulas now. So let's first derive a formula whenever E is missing, especially for this side. Let's first start on this side before going into this side, because negative formulas that involve negative sign are the ones that we have to tackle the most here, and our biggest concern, because they're actually the ones that where most people get confused on. So whenever E is missing, we have to do is move BC towards the left side of the formula, causing it to become negative. Therefore, negative BC plus A equals negative DE. And now, since E is missing, we have to eliminate D together with its negative sign. And then we're going to have a change of sign in the numerator. Now, our resulting formula would then be E equals the quantity of BC minus A all over B. Next one to derive is a formula whenever B is missing. So whenever B is missing, all we have to do is instead of BC being moved to the left side of the formula, it is negative DE to be moved here to the side. So that would make DE positive, and then A, and then BC here on the side. So right after that, since B is missing, we have to eliminate C, causing also this side to be divided by C. And then our resulting formula would then be B equals A plus DE, the quantity of A plus DE all over C. Must forgot to eliminate that C here. Right now we have here B equals quantity of A plus DE all over C. Whenever D is missing, same thing just like how we got D, all we have to do is to move BC towards the left side formula, causing it to become negative. Negative BC plus A equals negative D. And then since D is missing, all we have to do is to eliminate D. Also, together with negative sign, we got there we have it. And then we're going to have a change of sign numerator. Our resulting formula would then be B equals the quantity of BC minus A all over E. Since he's missing, all we have to do is to move negative DE to the left side from the causing it to become positive, just like how we got B. D plus A equals BC. Now since there's no negative sign here, there's nothing to worry about eliminating negative 1 or negative B. So let's remove B. That's our resulting formula would then be C equals quantity of A plus DE all over B. So here are the corresponding formulas whenever each of the terms are missing in the type of formula. Now let's move on to the addition or positive counterpart. So whenever each of the terms are missing here are the resulting formulas. So here are the corresponding formulas whenever each of the terms here in this formula are missing. Right, now let's move on to the next set of formulas here you can see on our screen. We have here A equals quantity of B plus C all over D, and A equals quantity of B minus C all over D. Let's rewrite that here. We have here A equals quantity of B minus C all over D. Right, so here are the two formulas now. We have here A equals the quantity of B plus C all over D, and A is equal to B minus C all over D. So let's first derive this formula here. This formula right here. So, how to derive this formula whenever C is missing? So, the very first step to do, even if B is missing or D is missing, all we have to do is to first eliminate the denominator. So how do we do that? This is right. Let's rewrite the formula. We have A is the quantity of B minus C all over. Then we multiply by D over 1, or just D. And then D also here. Causing us to have E equals B minus C. And then we have to move then B towards the left side of the formula, causing it to become negative. Negative B plus AB equals negative C. Negative C. Since we have the negative C, we have to eliminate that negative sign by dividing both sides by negative 1, because we're finding for a formula that has positive C on the non-negative C, so we have to eliminate that negative C. And here the numerator on this left side is going to be a change of sign. So instead of negative B to become positive B, instead of positive A to become negative A. So our starting formula would then be C equals B minus AD. So there we have it. Next is when D is missing. So when D is missing, same thing, we have to still eliminate that denominator. And using to the quantity of B plus C all over times D, and multiply here also. Then we eliminate the denominator. We have here AD equals B minus C. So since we have D here on this left side, we're going to have to eliminate A here. Since we have a formula wherein both B and C are all over A. So the formula would then be D equals quantity of B minus C all over A. Lastly, when B is missing, all we have to do again is to eliminate the denominator. A is equal to the quantity of B minus C all over B times D. Then we move negative C towards the left side, causing it to become positive. We have here C plus AB equals B. There we go. We don't have to divide both sides by negative 1 because B doesn't even have a negative sign. Resulting from B equals AB. So there you have it. Here, corresponding formulas whenever each of the terms here in this formula are missing. Now let us move on to the positive pattern part of this formula. So if you guys want to try and derive this formula 3 times because 3 of the terms are missing, feel free to pause the video. So the corresponding formula when each of the terms that are missing here are following. So all I have to do is just to change the sign. So instead of AD plus, you're going to have AD minus C. For C is just B plus B. And for D, we're going to have the quantity of B plus C all over A. So those are its corresponding formulas. So we have here now the two formulas. We have here A is equal to B plus C over D, and A is equal to B minus C over D. So let's first derive this formula right here. If you guys want to try and derive this formula into different formulas, whenever B and C or D is missing, feel free to pause the video then. So whenever we have this formula right here, let's say for example that C is missing. So whenever C is missing, first thing to do is to eliminate the denominator, which is D. So why do we have to eliminate denominator D first and not transferring or transposing B towards the left side of the formula? Later on you'll find out. So let's first try. Right now, A equals B minus C over D. Then we multiply it by having a fraction that has D on the top or the numerator and 1 in the denominator. But actually that's just D. To make us have an answer of AD. And then right after that we have AD equals B minus C. Now since C is missing, we would have that to be towards the left side of the equation. I mean in the left side of the formula, causing it to become negative B plus AD equals negative C. And now, since we have this negative sign right here, we have to eliminate that sign by dividing both sides by negative 1. And here in this side of the formula, we then have a change of signs. Instead of negative B, we have positive B. And instead of negative AD, instead of a positive AD, we will have a negative AD. Alright, so our resulting formula would then be C equals B minus AD. Next is when B is missing. So whenever B is missing, all we have to do is just to move negative CD towards the left side of the formula, causing it to become positive CD plus A equals B. So there we have it. Just rewrite it again. We have here B equals A plus C over D. Right, now lastly, whenever D is missing, the very first step that we have to do is to eliminate that denominator by D and also A at the same time. Why? It's because that once we did not do this fraction this fraction you see right here and just actually multiply that whole fraction by D over 1, we will generate a resulting formula that would make B even have a denominator of A in the end, which actually is wrong. We have to make B as a single term and having no division, or no fraction and no multiplication sign that's within it. This division will always have a multiplication in the end, and those with multiplication will end up as division once we get to derive those terms. Okay, so now let's continue. We have here A is equal to B minus C over D times D over A. That's good. We get to do the same thing here, which is D then we eliminate A in this side and eliminate D on this side, causing us to have a resulting formula of D equals B minus C over A. Alright, so there we go. Those are actually the derived version of this formula whenever each of the terms here are missing. So whenever b is missing, we would have formula of b is equal to a plus c over d. Whenever c is missing, we would have formula of c is equal to b minus ad. And whenever d is missing, you would have to calculate b minus c over a. Now let us move on to this formula you see right here. So whenever one of the terms are missing in this type of formula, the resulting formula's counterpart would be, whenever b is missing, we would have formula of a minus c over d. Whenever c is missing, we would have formula of b plus ad. And whenever d is missing, we would have formula of b plus c over a. There's only an opposite of those other counterparts in these formulas. So I read the last three formulas to derive. We have here a is equal to the quantity of b plus c all over the quantity of d plus e. A is equal to quantity of b minus c all over d minus e, and a is equal to b plus c squared. Now let us have those two. So we have here these two formulas now. This is a positive and the negative counterpart. Whenever b or c is missing, the very first step to do is to eliminate the denominator. We have nothing to do but just to do this as our best way, because we cannot actually move b and c towards the left side of the formula that easy, because it has a denominator, and this denominator, this fraction, actually signifies that it is a group term. So whenever we say group terms, they cannot actually escape by just changing signs from the right to the left side of the formula. So with that, we always have to eliminate the denominator. We'll also have to use this step, even if d or e is missing. That's because there's even no such thing as moving d and e towards the left side of the equation, right? So all we have to do is just to eliminate the denominator first. So let's do it. Times quantity of d plus e. And then also doing the same thing on this side. Seem to have restrictive property, and this one being eliminated. So we have here a d plus a e equals b plus c. Right, what we're actually doing here is to find c. So all we have to do then is to move b towards the left side of the formula, causing it to become c equals negative, or should I say ad plus ae minus b. Next is when b is missing. So whenever b is missing, same thing, we have to eliminate the denominator first. And now since b is only missing this time, we have to move c towards the left side of the formula, causing it to become negative. Alright, so I'm just gonna type that here. We have here b equals ad plus ad minus c.
Right, so we're now here in this part whenever D or E is missing. So if you guys want to try, feel free to pause the video. Now let's try whenever E is missing. So whenever E is missing, same thing, we also have to eliminate the denominator. And then moving AD to the right side of the formula. That is for us to be left with AE. And then eliminating A. Which would make us have resulting formula of E equals the quantity of B plus C minus AD all over A. Right, so whenever D is missing, the resulting formula would then be B plus C minus AE all over A. So that's actually just almost the same as the formula for E. It's just that we have here AE instead of AD. That's because D is missing in this part while E is the one missing in this part. Alright, now, when we're here in this kind of formula, and instead of being separated by a plus sign, it's going to be a minus sign. And so, since they are separated by a minus sign, there will always be a time that we are going to divide both sides by -1. Now let's try 1. We have here negative E, for example. So whenever E is missing, same thing, we're just going to eliminate the denominator as our very first step. We have A is equal to the quantity of B minus C all over the quantity of D minus E, then times the quantity of D minus E, and then same thing here, times the quantity of D minus E, which will make us perform the distributive property. Again, AD minus AE equals B minus C. Alright, and we move AD towards the right side of the formula because A is the one missing, which will make us have negative AE equals B minus C minus AD. Alright, now since we have this negative sign on AE, we have to eliminate that. And of course, since E is actually missing, we're going to eliminate also negative A. And then in here, we will have a change of sign, causing us to make all terms here in this numerator positive. Now let us rewrite that. The formula for E then would be E equals the quantity of B plus C plus AD all over A. Alright. one of the terms in the numerator. We have here b. So whenever b is missing, same thing. So we're going to have AD minus AE equals B minus C. Right, now since B is missing, we have to move C towards the left side of the formula, causing it to become positive. And our resulting formula would then be B equals C plus AD plus E. I mean AE. We can also move that C here on the last part after AE. And there we have it. So B is equal to AD plus AE plus C. So as you can see, they're almost the same. The formula of B here, the formula of B here, so that we have here C negative here and C positive here, because we generate the opposite sign whenever that there's that the sign of the original formula is actually also opposite. So, for example, just like in this formula here, we have a negative C. And so once we derive it towards the formula for B, we generated a positive C. While here, we have here a negative C. That's because of the positive C here in the original formula, which is for A. So now that we have formula for both numerators and denominators, so now that we have two formulas where one of them came from numerator and denominator, let's continue by generating the formula for C and D. So whenever C is missing, all we have to do is just to write that opposite counterpart of this one right here, and this negative B, instead of negative B, it will become positive B. And then instead of negative AE, we would have positive AE. Let's have it. D equals the quantity of B plus C plus AE all over A. Alright, so there we go. So move all the formulas here. Alright. So here are the specific formulas whenever one of the terms is missing these types of formulas. Right, now let's have the last. We have here A is equal to B plus C squared. Let's forget the negative counterpart of that, which is A is equal to B minus C squared. So this time we will have one term squared. Actually, the same thing we would do if two of the terms or another term here is squared. So how do you write squared? So let us say keyboard format. Here we go. Now let us try it. Whenever C is missing in this formula, all we have to do then is to actually move B towards the left side of the formula, causing it to become negative. Negative B plus A equals C squared. And then we're left with this formula. Of course, we're not done with that yet. So all we have to do then, in order to eliminate that squared, all we have to do is to square root it. Square root both sides. Okay. So after square rooting both sides, we are then left with the resulting formula, which is C equals square root of A minus B. So let me just add that square root. And there we have it. is when b is missing. Whenever b is missing, all we have to do then is just to move c squared towards the left side of the formula, causing it to become negative c squared plus a equals b. So essentially, we do not have to square root the formula. B equals a minus c squared. Right, now let's move to this negative counterpart of this formula. What if c is missing? Well, be aware of this negative sign, because actually we cannot square a negative sign. Because a negative sign is the product of two unlike terms. We have your negative and a positive term. So what we have to do then is this way. So let's see. We have here a is equal to b minus c squared. And then we move b towards the left side of the formula. We're going to have negative b plus a equals negative c squared. So since we cannot square root that, what we have to do is to divide both sides by negative 1 first, and then right after that square rooting it. So eliminating all those negative signs, having a change of signs here in the numerator. Since one would be negative, c squared equals negative a plus b. And next one, this is the only time we can square root them. Eliminating the square roots here. And then right after doing this, we would then have the resulting formula, which is c equals square roots of b minus a. Whenever b is missing this type of formula, all we have to do is just to move negative c squared only to the left hand formula, and then we have the resulting formula, which is b equals a plus c squared. So we have here are the corresponding formulas where one of the terms are missing in each of these formulas.
Deriving equations and formulas can actually go in two ways depending on your choice. You can first derive the equation or formula, then substituting it afterwards, or you can proceed with substituting the elements of the equation and then deriving it. So that's it for the part 2 of deriving equations and formulas. I hope you guys learned a lot. Thank you guys so much for watching this video, and I thank you very much for your continuous support for Mad Magic. Especially that even if I was gone for a few months, you guys still showed your never-ending support by liking and following my page. Thank you guys so much, and I pledge to give you more videos, especially that there are lots of time this summer I can actually make lots and lots of stuff about math. And in our future videos, we're going to tackle more about calculus and as well as the importance, the application of a lot of math topics which seem difficult. However, it has a lot of use to us. So we'll get another video of Mad Magic. I'm Aaron Racer, telling you to stay safe and keep following Mad Magic. Bye!